Hello friends, welcome to Aravalli Geo Academy. Today we are going to discuss the next part of the earth and its atmosphere. So first today we discuss the vertical structure of atmosphere. Number first, gravity pulls air molecule toward the earth. Okay, actually gravity is responsible for the gravity pull the air molecule toward the earth surface, and this pull compress air molecule closer together. Okay, due to the gravity air molecules come closer. Okay, and closerly packed in particular volume. Compression increase in number of molecule in the given volume. Okay, because gravity pull air molecules toward the earth surface. Okay, and due to this pull the air molecules compress. Okay, and due to this compression in particular volume molecules are increased. Okay, more air above a level means greater compression below. Okay, it means if above the surface the air molecules are greater, then the greater the compression will there. Okay, due to the greater number of air molecules. Okay, now we discuss about the weight. Weight is the force on object due to the gravity. Okay, and weight is defined by mass multiplied by the acceleration due to gravity. See this formula: weight is the mass multiplied by the gravity. Mass is the amount of matter in the object, and mass remains constant everywhere. Okay, in the universe, but weight is change everywhere. Okay, mass is the constant. Okay, weight change depending on the gravitational force, we know that. And in at the moon the gravity is weaker than earth, so weight is also less as compared to earth at the surface of the moon. So the object is a mass stay in the same mass, always same everywhere. Okay, but weight depends on the gravity. Okay, density of the air depend on the mass of atom and the molecule and the space between them. Okay, density of air depend on the mass of the atom, like the atom like the nitrogen, oxygen or other, and space between them. Okay, so density formula of density is the m by v, mass by the volume. Air density highest near the earth surface, because air molecules highest near the surface, so air density is also highest near the surface. This is because more air molecules are packed into the same volume near the earth surface. So in the particular volume air molecules are greater. Okay, it means a particular volume the air molecules are greater, then density is also greater. Okay, so focus on this diagram. This is very important. Okay, first focus on this air column. Okay, this is the 1 inch wide and this is the 1 square inch. Okay, area of this air parcel is the 1 square inch. Okay, and weight of this air is the 14.7 pound. Okay, now focus on the air molecules near to the surface as well as the at the height. Okay, so near the surface, due to the gravity, this gravity pull air molecules toward the earth surface. Due to this gravity, okay, in the particular volume air molecules are concentrated at the particular volume. Okay, so due to this compression density is higher near the earth surface, and when move upward. Okay, when we move upward, then air molecules are decreased in the particular volume. Okay, so density is also decreased. Okay, now focus on this graph. Okay, this is the density. Okay, or air pressure, and this is the altitude, height. So we know that near the earth surface the air molecules are actually concentrated, so density of the air is the greatest. Okay, and when we move upward then air density is continuously decreased. Okay, also remember, first air density decrease sharply, then slowly. Okay, and same is the pressure, because the pressure is actually Pressure is also highest near the surface because concentration of air molecule is highest near the surface, so pressure is also highest near the surface, then decrease slowly. Okay, first decrease sharply, then slowly, like the air density. Okay, so remember both the point, pressure and density first decrease sharply, then slowly. Okay, now next, as we go higher in the atmosphere, air density is decreased. Okay, air density initially decrease quickly, then slowly. Okay, with the height. Near the surface, air compressed due to the gravity. Okay, and remember the pressure it means force in the particular area. Okay, or air pressure it means force of the air on particular area. Okay, then this is the about the a column of air 1 square inch wide from the sea level to the top of the atmosphere. Weight of this air column is the 14.7 pounds, and the normal atmospheric pressure at the sea level is approximately 14.7 pound in square inch. Okay, this is the actually area of the air parcel, or in this air parcel the atmospheric pressure is a 14.7 pound square inch. If the more air molecule are packed into the column, then become this is the denser. Okay, air pressure can express in the different unit, like mostly we use the millibar unit, but we can also use hectopascal and inch mercury barometer. Okay, mercury. So near the surface or at the surface, the pressure is at 1013.25 millibar, or in hectopascal this is the same value, because 1 millibar equal to 1 hectopascal, or this same value in the inch mercury barometer is the 29.92. Okay, so remember the old value in the millibar as well as the hectopascal as well as the inch mercury barometer. Okay, so this is the average sea surface temperature. Okay, sea surface pressure, uh, this is the standard value. So billion of air molecule constantly push on the human body from the all direction, but we are not crushed. Why we are not crushed? Because molecule inside our body push outward with the equal force. Though we don't feel this pressure, we can sense rapid change in it, because equal pressure is also working outward. When we climb quickly in the elevation, our ear may pop. Okay, why? Because air pressure outward of the eardrum is decreased. Due to this decreasing air pressure, when we move from surface to the higher elevation, then pressure is continuously decreased. Okay, so our ear may pop due to the decreasing the air pressure, outward decreasing air pressure. Okay, uh, outward the eardrum pressure is decreased, so our ear will pop. Okay, the total weight of the earth atmosphere is about 5.08 into 10 to the power 18 kg, or same 5600 trillion ton. Okay, so remember this is the factual point, what is the weight of the earth atmosphere. Then air's weight exerted a force on the earth's surface known as the atmospheric or air pressure. Atmospheric pressure is force per unit area exerted by the molecules. Okay, atmospheric pressure decrease with the increasing altitude. We know that atmospheric pressure as well as the density is also decrease with increasing altitude. The decrease in pressure is rapid at the lower altitude and slower at the higher altitude. Pressure decrease first rapidly, then slowly in the higher altitude. At the sea level, atmospheric pressure is typically around the 1000 MB millibar, and just above the sea level, pressure drop about the 10 millibar per 100 meter. Okay, it means 100 millibar per 1000 meter. Okay, this equal roughly 1 inch in mercury barometer. Okay, 1 inch drop per 1000 feet. Okay, in the mercury barometer. At the 5.5 kilometer altitude, air pressure is about only 500 MB. At the surface, around 1000 MB, or at the 5.5 kilometer, air pressure is only 500 MB. Half of Earth atmosphere molecule lie below the 5.5 kilometer elevation. Okay, and above the 5.5 also 500 MB, and below the 5.500 actually 500 MB. Okay. See, this actually graph is very important. Okay, this is the air pressure, or this is the altitude. Okay, so at the surface the pressure is the 1000 millibar. Okay, and when we move in the higher elevation, then pressure first decrease rapidly, then slowly. Okay, so at the height of the 5.5 kilometer, the air pressure is the 50%. It means only the 500 millibar. Okay, at this height, or at the height of the 17 kilometer, the air pressure is only 100 MB. It means 90% atmosphere lie below the 17 kilometer, or 50% atmosphere lie below the below the above the 5.5 kilometer. Okay, above the 5.5 kilometer, only 50% atmosphere is there. Okay, and above the 17 kilometer, only 10% atmosphere is there. Okay, or at the 32 kilometer, the air pressure is only 1%. Okay, 99% atmosphere lie below the 32 kilometer. Clear? Or also remember, at the Mount Everest, okay, the air pressure is only 300. Okay, 300 MB. It means 70% atmosphere lie just below the height of the Mount Everest. Only 300 millibar is pressure here. Okay, or we can say uh, above the Mount Everest summit, only 30% atmosphere is there lie. Okay, above the Mount Everest, and 70% atmosphere lie just below the summit of the Mount Everest. So at the Mount Everest summit, air pressure is about 300 MB. Okay, or we already know this 300 MB is the only 70%. Okay, the summit is above nearly 70% atmosphere of the whole atmospheric molecule. Then next, at the 50 kilometer, the altitude air pressure is drop about the 1 millibar. Okay, because above the 50 kilometer, only 1% atmosphere is there. Okay, and below the 50 kilometer, 99% atmosphere is there. 99.9% all air molecule lie below the 50 kilometer elevation. The atmosphere become progressively thinner with the height, because when we move from surface to the higher level, then atmosphere will progressively thinner because density is decreased continuously. So thank you. This is all about the today's lecture. We will meet tomorrow. Thank you.